All right, good afternoon, Warriors. I hope you are well and having a good week. Here's where we are on our first prep session, one of two. We'll do a second one on Thursday. They won't be the same, so don't worry about that. And I do want to highlight I don't know if I'd talked about this in a little while, but our final is a week from tonight. We ride for the last time. Tears of joy, I know. So, um, right now, we're looking at 5 o'clock to 7 o'clock is the official York College schedule. I don't think we have anybody behind us, so right now I'm going to say 5 to 7:30. I don't think I can start any earlier than 5, but I think I can go a little bit later. So that's what I'm looking about at right now. I don't see that changing much. We can talk about that as we go. Here is our map check for tonight. We're going to talk about a lot of things. I'm probably going to spend the most time on descriptive since we haven't talked about that in a while. And then we'll set conditions for what we're going to do on Thursday. On Thursday, we're going to do a we drive, our final we drive, the best we drive of it all, called Joker's Wild. Right before class tonight, I updated at the last minute with a lot of things, and Joker's Wild is on there. So I'll talk some more about that as well. Then looking at Friday, two things. One is I'll post your class interaction and participation assessments, which leads me to the side note of assessments. All assessments on Canvas at this point are up to date. So that was the final regression assignment, final Pearson, and I think that was it. So everything that quote I owe you is on there. If you haven't had a chance to look at that, I encourage you to look at that to see where you're at. And if you have any questions, please let me know so we can talk about it. And then I'll talk here about reading day. So the grayed out times on the screen are the ones that are taken. And I need to add this one too. So, if you would like time one on one, you and me on Zoom on Friday, then just let me know. And it's that easy. Okay. If you don't, that's cool too. But it's there for you to take if you want a little bit of a last minute injection of validation, whatever it is, that kind of thing. Okay. Here's what we're going to do tonight. We are already recording. Um, I have about ugh, like 9 slides. So my intent is to just kind of cover a bunch of things at kind of treetop level and then come back and take a second pass and go deeper into descriptive, talk about descriptive and do some work with you on the screen on Excel, and then pull back out, talk about how to prepare for the final. Okay, I have one slide on that. So before we begin, do we have any questions, big or small, from anyone? Okay, it's not a one-time question, so if you have them, ask away. So let's talk about the final. Just kind of start easing into this. Again, it's a week from tonight. That's this time next week, 5 to 7:30. I'll have it available on Canvas assignments immediately at 5, and then probably close it at 7:30. I'm looking at 105 to 120. Yeah, I'm sorry to kind of sound wishy-washy, but I'm about 80% done writing it right now. I don't see it being less than 105 or 100, and I don't see it being more than 120. Um, So it'll appear on Canvas, both in assignments section, and I'm finally smart enough. Don't applaud for me just yet that I can make it appear in the main page. It'll take you right to the assignment. So you don't have to go on an Easter egg hunt or anything like that. It will be in a similar format as before in terms of the Excel packet with multiple tabs. This time I'll put an extra thing in there to tell you right up front. So you open it to the instruction page, you know how many questions you're looking at, that kind of thing. As always, just because it's in Excel, really the only thing you have to do in Excel is to enter your answers in Excel. You could theoretically do all the rest of the work out of Excel. That's up to you. There are certainly parts that I would encourage you to do in Excel simply for the time savings and the peace of mind kind of thing. But none of that has changed from what I've talked about in the past. And then access refers to me. I will be standing by during the entire time that you're taking the exam, and I will be accessible through phone and email. I'll have all that information for you. So, bottom line is no deviation from the method that we've done in the past. And I think went pretty well, but of course, I'm going to say that. The hit list. So, bottom line, the things are in bold. I got asked this question earlier. Is the exam weighted? Is it comprehensive? Well, the short answer it is cumulative. It does cover it to some degree, everything that we've talked about in this course. That being said, I put in bold hypothesis testing and regression because we haven't had that on an exam yet. So if I was a betting person, I would bet pretty heavily on the fact that you're going to see some hypothesis test questions and some regression question, maybe singular, maybe plural. Um, at the same time, I'd be ready to do everything, and we'll talk more about that. I do think that if you follow my recommendations for preparation, that you will be as best positioned as you can, and all that, and some of that depends on your choices, as always. Okay. So I'm going to come back to descriptive because I'm going to spend the most time there tonight, and I want to just talk about a couple other things, really at treetop level. These aren't the last time we will talk about these things. We will do more practical work on Thursday. So I'm trying to balance the use of our time. If you have questions, you want to talk more about these things, either now or Thursday, we certainly can do that, or one-on-one. So just want to talk somewhat quickly first about sampling, and I think I kind of get the vibe that across the board between you all and my other group of warriors and the 102 crew, sampling is one of these things that probably tricks up more people than not. So let's just kind of go back to the basics a little bit in thought process about what sampling is, why we do it, what we're trying to accomplish. We if I could count or capture all the data about a group, for example, you all. So I wanted to find out something like how many people have stopped exercising since the quarantine. And I wanted to find that about you all. Well, I could find that out. That really wouldn't be very hard to find that out. I'd ask you to do it. Maybe I'd motivate you, with some extra credit. Maybe I'd threaten you. I don't think I'd threaten you. But the bottom line is that with, 20 some of you, that's not hard to do. So I don't need to sample because I could find out everything. That's that population that's accessible. It's small. It's relatively easy to get to. I sample because of my other types of populations. So if I was interested in all sophomores or all juniors at YCP, how many of them, or you all included, have stopped exercising since COVID, then I would probably need to take a sample. Because if I tried to count and capture all of that data, I wouldn't be able to do anything else. And I probably just wouldn't be able to get the data. I just wouldn't be able to get hold of everybody. And at some point, I'd have to start making assumptions. And so we have sampling is kind of my way out of that. But in terms of the bullets on the slide, sampling is also used when I know information about the population in the first place. And this isn't always in a supply chain kind of production aspect, although that's a common example of it. Hence, that's why I teach this class. So, for example, um, Tim works at Panera, and the company standard or population process standard is to put a certain amount of chicken on each chicken sandwich. I think it's like 1.7 ounces, if I remember correctly, or 1.7, 1.8. So that's a population parameter. And Tim wants to know if within his respective Paneras, if they're doing that. Well, he's not going to pull down every single bag of chicken that's been cut for the day because he's got other things he's got to do. And so he's going to pull a sample. Okay. And so in that instance, Tim is sampling to see if his respective Panera is operating in conjunction with which how all Paneras are supposed to operate. So in other words, he has information about the greater population. That's why he's taking a sample to see if his little piece of the world, his Paneras, is operating the way it should be. Okay. So oftentimes it's from population down. We want to sample because we want to see what's going on. If he took a sample, he'd have probabilities based on his sample size, based on his population mean and standard deviation. And before he cracks open that any one of those, chicken bags, and before he writes his sample mean on the board, that population parameters give him an idea about what he should expect to see. So, for example, let's just say that the population mean is 1.7 with a very, very small standard deviation. Then Tim knows he should expect to see the majority of the bags somewhere a little bit less than 1.7, somewhere a little bit more. And so when he starts pulling bags out and they're tipping the scale at like 5 pounds, he goes, "Whoa, this is not what I am supposed to be seeing, not even close." So something weird is going on here. Or conversely, he pulls out the bags and he's averaging the numbers and he's going 1.76, 1.74, that kind of thing. Wow, this is what I should expect to see. So that's why we use sampling, uh, where we have an idea about the greater population and we want to find out if our particular piece of the world is going the way it should. And of course, to do that, we need an idea of what we should be looking at. So there's kind of an overview of sampling. Now, in contrast, confidence intervals is a little bit of the opposite. So in confidence interval, as opposed to where I'm sampling because I know kind of what those larger populations should look like. And I just want to see if my particular way in the world looks like that, or if it's different and maybe take action. Confidence intervals is a little bit in the reverse direction. And I think is more appropriate to new processes, new ways of operating, emerging things, and emergency things. So, for example, this whole COVID kind of thing. If I didn't have any higher population information about the amount of people that have stopped working out, then I would probably want to approach this from a confidence interval perspective. So I might try to take a sample of college students and ask them, hey, have you stopped working out since COVID? And then use that sample to make an inference about the larger population. Okay. Because I doubt, well, maybe now since we've been in quarantine for a while, but maybe it's still not now. If I Googled, hey, how many people, what's a national, soundbite on the amount of people that have quit working out? I really, it may be that someone has collected and analyzed that information, but it very well may not be. Okay. So that's kind of an example of a new process. But it's not always. So if you look on the screen, kind of hand in hand with this thought process is when to use the T distribution and when not to. And now I'm starting to get into common errors I've seen, both with you and with other warriors and warriors past. And I don't like the word error, so I apologize for that, but the things that kind of hang us up. Um, so when we don't, when we're taking the sample, it seems to me that we don't really know much about the greater population. So when we don't, and we don't know the standard deviation of the population, we're going to use the T distribution. Okay. So the $1 million question is, if we're doing a confidence interval, i.e., we're trying to estimate something greater about the population, either the population proportion of people who have quit working out, or maybe the population average, the amount of time people spend working out now that they're in quarantine. Either one of those instances, of course, with the population, I'm always going to use, or proportion, I'm always going to use the Z distribution. With the population mean, I have to ask myself, do we know the population standard deviation? I think the only case in which we would, and it's just very hard for me to see when we would, is when we had some kind of expert give an opinion on some kind of variation and say, well, I don't know what the population mean is exactly because we haven't collected that, but I would, based on this, that, and the other thing, I would think the variance among people is 30 minutes or something like that. So if we have some kind of expert that makes that statement, then we could use that as a population standard deviation. But for all you, if you don't see it in the narrative, you're in T distribution land. Okay. And when in doubt and you're just like, I'm not clear, give me a call. Again, the worst thing I can say is, hey, I can't help you. Please don't confuse population standard deviation with sample standard deviation. Okay. Related, but not the same thing. Okay. Sample standard deviation is simply the variation among my values in the sample. Okay. I asked Alexa, how much time do you spend? I asked Connor, I asked Delaney, and I add all that together and I'm going to get an average and I'm going to get a standard deviation. Okay. But that's not my population standard deviation. So, just assess yourself and say, rhetorical question out loud, but am I comfortable recognizing when to use T and when not to when generating a confidence interval? And then finally, please write the confidence interval completely and correctly. Now, let me fire up my pen just to talk about what I mean real quick. And I owe you some more guidance of how to do this on Excel. In fact, I'm just going to show it to you. Probably not today, but on Thursday, I'm going to show you how to do it and give you some options. And then you can make the choice that you want to make. So, back when I was a paratrooper, we always talked about show people what you want first and then show them what you don't want. Okay. So, to me, an example of completely incorrectly looks something like this. Number one, we have our centerpiece right in the middle, our main attraction. That's going to be one of two things. It's either going to be the population mean, mu, or the population proportion. Okay, it can't be both. It's going to be one or two. And then it's going to be surrounded by greater than or equal to, less than or equal to. And same here. Okay, so these are examples. This is not all one example. And then we're going to have numbers on each side. These numbers up here, I don't know, they're going to look like something that a mean would be. Okay. And this number is going to be less than that. I'm just kind of making these up. Don't get confused by that. These could just as easily, the mean of something could be 0.45. and 0.35. But down here, we're either going to have a percent. Personally, I like the decimal because that's what I see used the most. Okay, so what's the difference? Well, down here, unless you put a percent on the end, you're not going to have a number like this. And even if you do, there's no such thing as 168% of the population. Okay, that's just not a thing. You could have 100% of the population. I think it would doubtful that you would come up with that, but you're not going to have 100, you're not going to have 168% of the population. That just is not a thing. So this is what I mean when I say completely incorrectly. All right. We have the symbol in here. We have these symbols right here. We have values out here. And for the most part, this is what I've seen. Now, something like this is what we used to call back in the day a no-go, meaning not so much preferred. This is incomplete. Something like 155 plus or minus 2.58 times the square root of 0.5 times 0.5 over 200. See what I mean? This is almost kind of like we stopped at the 10-yard line and didn't put the ball in the end zone. If you run out of time, this is better than nothing. This doesn't mean 0 points. You guys know me by now. But down here, let's just get the symbols straight. And I'll give you more guidance on that on Thursday, so you're clear in your mind kind of what you need to do. In one way, you could just handwrite this if you wanted to, but if you want to do it in Excel, that's cool too. There's ways of getting this symbol in Excel that really aren't that hard, and these symbols too that aren't that hard to do. So I will give you more specifics on Thursday and in writing about this piece right here so that there's no doubt in your mind. Okay, so that's it on confidence intervals. Let's keep on moving. Okay, here's one of these things that you have to ask yourself, does this kind of chart help me or hurt me? If it hurts you, then don't use it. Okay. Some of you probably don't need this chart. Okay. It's not a requirement by me. I only share it with you as a framework to help prosecute problems. Okay. But it's kind of like Michael Jordan. Michael Jordan doesn't need someone to tell him the 10 steps of how to dunk a basketball. He just goes and dunks a basketball because he's really good at it. And if he had to explain the 10 steps to dunking a basketball as he was doing it or trying to do it, that would probably be kind of a mess because he probably doesn't even realize half the thing he does all the time. So what is that? How does that tie back to you all? You need to assess if you need this chart, if it helps you or not. The reason I provide this chart is so that if you are having difficulty with sampling problems or confidence interval problems, you can kind of identify, like a surgeon, where you're having problems. Now, if you feel like you're having problems everywhere and it turns out you are, then so be it. But most of you are not having problems everywhere. Most of you, I think, with some guided reflection, you can narrow down where, what problems really kind of give you a hard time. And once you do that, in my opinion, 51% of the battle is over because you're like, now I figured this thing out. Now I still don't know the answer, but I can find this thing and kill it. All right. So the point of this slide is, again, framing. What kind of problem am I looking at? Am I looking at a single value, a sampling, or confidence interval? And then, going further from there. Some of you might want to modify this slide and say, hey, I don't need this part. Maybe I just need this part. I don't know. But I do think this slide could be helpful for you to assess yourself and just kind of as a readiness thing. Do I know how to do that? Yeah. Do I know how to do this? Yep. Do I know how to do that? Yeah, no. And then kind of go from there. Again, I just want to be clear. This is nothing that is required. It's just my effort to take a kitchen sink of kind of complicated things and put them into a Christmas tree where you go, oh, okay, I recognize a Christmas tree. And then you can go from there. So it's my attempt to make something that's relatively complicated a little bit simpler for you to dissect and fight through. Um, okay, hypothesis testing. This is where we spent a lot of time lately, um, and we'll spend some more time in the coming days. But let's just talk about the big ticket items here. And so, first things first, to me, I think the easier part of hypothesis testing, although it may not seem like it, um, is once you get past the null and alternative hypothesis. Because once you get that stuff straight and everything that goes with it, the remainder, until you get to include to interpreting the conclusion, which we'll talk about in a minute, but the stuff in between is relatively easy. Um, there's procedures, there's values, there's hack tables, there's some variation in procedures, but to me, the big thing that tricks people up and myself is this right here. What is the null and what is the alternative hypothesis? And just being able to do that, and then on top of that, write that correctly. So what I'm going to do just now is talk about some handholds, none of which are new, that may help you take this difficult thing and diffuse it a little bit, so it's not as difficult. So that you can kind of put some familiar things in place. And, kind of like with that Christmas tree, well, I know where the lights go and I know where this goes. And then you can spend your mental energy on the tough things, like where's that ornament that's been in my family? Where do I hang that's been in my family for 10 years? Where do I hang that one? So that nobody gets upset with me, kind of thing. Not that, not that this ever happened to me. It hasn't. I'm just making it up. So, um, one technique is to load the alternative hypothesis in first. That could work. We got to be careful. One of the simple handholds to me, and when I talk about handholds, I have this friend who's a firefighter. He told me one time they actually, um, like Braille, they make the hoses a certain texture. So when you're in the dark, if you feel a certain way on a hose, it'll tell you you're going away from the hose. And if you feel the other direction, you're actually going to where the hose is connected. And the point of all that is so they can find their way out of a dark room if they get lost and misoriented, which with all that kit on, I could see that happening all the time. What's the analogy here? Well, here's how to make some handholds for you so you don't get lost in that dark room when you start going into this. One of the big handholds is the null hypothesis will always, always, always have some sort of equal sign in it. Always. It'll either be a double like this one on the left, or it'll be part of a greater than or less than kind of thing. Okay. So you can have comfort in that. The trick is, which one am I looking at? And then you can also have comfort that if you have this, you will have that down there. Okay. So these are handholds in the dark, which I say, okay, well, it's not as dark anymore. Cool. All right. A second handhold is that the number you pick, and in my opinion, the number that you want to load in is the one associated with the status quo, which is the null. Okay. So again, that number that you load over here You can do it in either direction. We'll just start with the number first. Let's say that is 155. Well, if it's 155 there, and that's the number associated with the status quo, it's got to be 155 there. These numbers have to be the same. Okay. So spending the time and getting comfortable with that handhold is another confidence thing. You're like, okay, this is cool. Right now on this one, heck, I got whatever, all I got to do is fill in this over here. Okay. And let's just say that it's 155 and 155 over here. Okay. Let's talk about this side. So on this side, I have two choices. It's going to be either the proportion population or the proportion mean. I'm not going to have X bar. That's not going to be there. I'm not going to have little p. That's not going to be there. I'm not going to have little pump. Just kidding. That's not going to be there. All right. There's going to be one of these two dudes up there. I got to figure out which one it is. And I have keywords: average, population mean. That would be this one. The population proportion, something that starts out with 30% of all people in the world, like the nitro cold brew. That would be this one. Okay. Let's just say for our example here, it would be this one. And that all makes sense because this 155 as written, again, to beat a dead horse or at least resurrect it so I can beat it some more. That 155 written is not a population proportion. Just can't make it work. 155% doesn't work. All right. So if you have a number like this, it's probably a cue that that's some sort of population mean. And let's go ahead and run with this over here. So if we're on a two-tailed test, we're golden now with those handholds. Are those handholds bulletproof? How do you get those handholds? Well, if you're really confident those handholds are good, you're building your way to being bulletproof and you won't get lost in that dark room. This dude is probably the toughest to figure out. Okay. No matter what, we're not going to put that equal sign down there. We want to, I really want to, we're not going to do it. We're going to resist the temptation. All right. What we've got to do is read the problem and say that status quo, what is that status quo? Is the status quo saying that it's normally equal to or less than 155? Then that goes there. And if we feel good about that, all we got to do is the opposite down here. Okay. So I personally think that it's worth the time to look at different problems and just not even do the whole problem. Just do, like we did in the past, the frame game. That's the whole reason that we did that, is I wanted to get you into the habit and comfortable with this piece here. It's not that you shouldn't know how to do the tactical step-by-step portion of the p-value method, critical value method, and all that stuff. That certainly is important. But if you don't get this right, you could potentially have this reversed or wrong. And then when it comes to interpreting, you're going to be trying to squeeze like a square peg into a round hole. You're going to be trying and going, I don't know why this doesn't work. Well, it doesn't work because we have something, not correct up here. So let's talk about that for a second. Interpreting your decision within the context of the problem and situation. Remember that rejecting the null or failure to reject the null is not, that's your statistical decision, but your overall decision is kind of what actions would you take now? And that's really what we're going for in terms of the interpretation. So rejecting the null is not the interpretation. The answering the question, what do we do now? What does this person do now that we rejected the null? So let's say that I'm marketing. I'm trying to sell a virtual coaching app. And the virtual coaching app works best with people who work work out more than 155 minutes a week. And so, but it doesn't work well with less than that. So I could do either one of these, okay, hypothesis tests. This one over here would probably be more appropriate. Okay. And let's just say that I use this one here. Okay. And I reject the null hypothesis. Well, interpreting my decision in the context of the problem situation. So what do I do now? Well, now I have sufficient evidence to pursue my app and marketing it, because the amount of time that people work out in quarantine seems to have changed from 155 minutes. And heck, that could be my slogan going in. Stuck at home, not much to do, getting cabin fever. I got an app for you, kind of thing. Sounds pretty cheesy. I know. You don't have to say it. I got it. Okay. But the main thing, and now let's say the reverse. Let's say I fail to reject. Well, that marketing plan is not going to really work. Maybe I need to redesign the app. Maybe I need to have different versions of the app. Maybe I just need to go back to the drawing board. Okay. So, you know, knowing the bookends, the front part of that hypothesis test, what the null and the alternative is, the more that you can figure that out, that will make it easier for you to interpret the whole thing once you reject it and not reject it. Okay. So try to achieve a balance there. I know that sometimes when we get working with hypothesis tests, we get into all the nuts and bolts and it becomes overwhelming. And I just need to fight my way out of this. Hooray, I'm finally done, reject or not reject. But let's get into the end zone too and put that into context. Okay. And it doesn't have to be complicated. It doesn't have to be a dissertation, just a couple of sentences saying, hey, this is what this person should do now. Continue to explore by doing X, Y, and Z, or hey, go back to the drawing board kind of thing. Okay. And then this slide is one you've seen at least 3 times. This is, again, you may not need this slide. It certainly isn't required. It's just my attempt to take something that seems very complicated and break it down. So again, reading it left to right, the first question is, what kind of situation am I looking at? Am I looking at a population proportion or something dealing with a mean? And if I'm dealing with a mean, do I know sigma, the population standard deviation, or not? And then based on the answers to those questions, I can keep on moving to the right. Okay. Again, very much like confidence intervals, making this, differentiation down here. Do I have a process standard deviation or a population standard deviation or not? That is key. But then from this point on, it's much easier. We still have the nuances of the p-value and things like that. But a lot of time it's just getting past the frame of the problem. So again, if you look at this and you just want to throw up and this is not helping you at all, well, we need to go back to the drawing board and figure out something that will help you. But if it is helping you, then use it as kind of much as you need to. And if you're like, hey, I kind of can do this without the chart, then as the saying goes, if it ain't broke, don't fix it. Okay. All right. And then regression. Here we want to examine the relationship between 2 variables. I think what is key, and I think I saw it less so in your group and our group than my other group, was identifying which variable we want to establish as being independent and which one being dependent. Okay, so just to talk briefly about the regression assignment, what we were doing is we were taking Epiphany around and trying to sell it at various places. And so a few folks said, well, how would I know that Epiphany in that situation was the dependent variable? Well, part of it, reading back over the question, was the questions we're asking, if we sold 800, gaming tickets, then how much Epiphany would we sell? Well, and I think the question even more specifically says, how much Epiphany would we predict selling? So there, the question is saying, if I sell 800 gaming, that means gaming is independent in that context because I'm using the gaming information to base my prediction for Epiphany. Okay. And that is X, using X, the 3D gaming, for my Y, which is Epiphany. Okay. So that's kind of a telltale indicator. Another indicator is something in the narrative that might say, we have reason to believe that Epiphany, the sales of Epiphany, are dependent on the situation and the setting that it is sold in. So that's a lot more direct. But the main thing is you want to figure out what is your independent variable, your X, and what is your dependent variable, your Y. And just like the null and alternative hypothesis, it's not the same thing, but that is strategic in nature. You want to make that separation up front. And then everything will, has a better chance of falling into place. I think that the most common thing I saw was people getting those confused. And in Excel doesn't like it if you get those confused. You can't they're not irreplaceable. So you can't switch values from being X and Y. When you do that, you'll get different slopes, different intercepts, and therefore different predictions. So you've really got to feel comfortable identifying what is independent and what is dependent. Okay. And look for ways. And I'll do a little bit of thinking in between now and Thursday, maybe come out with a simple handout that gives you some of those keywords. All right. I know I've been doing a lot of talking, probably too much. We're going to do this here for the next 20 minutes or so. Really just to refresh our brains on descriptive statistics and some key things in here. Okay. And so what we're looking at here in this example is we're looking at two small populations of people. Let's just say that Alexis and Carrie are both headhunters for Delaney. Delaney is a big executive. She has a company. She has 24 openings. She's going to use, but she doesn't want to split kind of these populations. So Delaney is looking for a group of 12 people with a high IQ. So these are all IQ scores. And I think the average IQ is like 110 or 100. I forget. I should know. But that doesn't really matter in the context of this problem. So we'll just say these are Alexis's scores for the people that she recruited. And these are Carrie's down here. Okay, so we've already interviewed these people. We hired them. We're on the payroll now. Delaney is we're trying to provide some analysis to her on which group she should put in these 12 positions that require higher IQ. Okay. So, first things first, this right here is a frequency table. All right. As is this. And from this point on, I am going to give you this kind of framework right here. Not necessarily these values, okay? But I'm going to start you out. I'm going to give you some data. It'll probably already be sorted. And I'm going to give you the framework on how to split the scores and the midpoints. That's what MIDI stands for. Okay. And the reason I'm going to do that is because if I just said split up the groups the way you want to, conceivably I could have 23 different ways of doing that. Okay. So I'm just going to give you that framework, But when I give you a frequency table and I ask you to fill out and complete the frequency table, I want you to do what we're doing tonight, okay, which is complete the table. So the first things first, we're going to identify the frequencies in the respective group. And if you're like, dude, this is so yesterday, I know how to do that, then that's good. That's good. That's definitely where we would prefer to be. So to identify how many are in the 100 to 109 group, we're going to go down this column, okay? And we're going to count how many are between 100 and 109. All right? So Nick, what would that number right there be?
2.
2. Okay, very simple. I'm just going to do a little bit because I think you guys know how to do this. So for my next group, 110 to 119, I'd have 101 plus 114, which is 2 there as well. And then 120 to 129, I'd have these folks. So that would make that 3. And then finally, 130 to 139 would be starting here to there, would be those 3. And then 140 and greater would be those final 2. Okay. And I slapped this Excel spreadsheet again is up on your canvas. I put it up there at the last minute. So you have this, and I'll post the filled in version as well. Okay, so we got to do a very important thing right now before we go on. Chastity, do you know what that important thing is? Can you tell us what that is?
I'm sorry.
All right, you're muted now, so.
I asked if you could repeat the question. I'm sorry.
Yeah, it's all right. So we've got these frequencies, 22332. What do you think we need to do now?
We're doing the relative frequency, so we have to total them all up. And then I'm trying to think of how you do it. Yeah. Oh, and then you, on the relative frequency, you take the number, like the first number. So I guess it would be H2, and then divide that by the H8.
Okay.
And then put the H in dollar signs.
All right. Because that cash thing? No. All right. Super. Outstanding. Okay. So I'm going to put those dollar signs around like Chastity said, so I can protect that value and save myself a little bit of time. Not that I'm in a hurry, and just drag on down. Okay. So right off the bat, I see some interesting things. I see that my highest concentration within this population is right here within these groups. So between 120 to 139, those groups add together to be 50% of the entire population. Kind of interesting. Okay. So to do cumulative frequency, I'm going to take this value here, relative, and I'm just going to leave it there because these are already sorted lowest to highest, and I will give it to you that way. All right. So to keep going, Delaney, what do I do now in cumulative frequency?
Next, you would want to calculate the,
Okay, Travis, what do you think? What do I do now? I've got my first cell for cumulative. How do I continue?
Wouldn't you do? You would take the previous cumulative frequency, or you said it, you go equal, then and then you do plus, and then wouldn't you do the one next to it?
Yes, I
Correct?
would. That is
That
correct.
one. Yeah.
All right. So that value there, 33.33, means that 33% of this group up here has an IQ of 119, between 119 and 100. That's what that number means. Okay. And I'm going to go ahead and drag that all the way down. And I have that beautiful 1 right there. Okay. Which is my check that all my stuff added correctly. I opened the spreadsheet earlier to get ready for this class, and I looked right there, and it was like 0.975. I just, and you know what I was wrong was this number right here. So we talked about this number before. The reason, not only do we need that number to get these numbers, but the other thing that we need to make sure about that number is that it matches with the number in our population. Okay. And what I had going on earlier was, I think I had this number is like 11 or 9 or something weird. You see how that gets all jacked up like that? Technical term, excuse me. So we want to make sure those numbers match. All right. Now that right there is our frequency table. Okay. So if I ask you to complete the frequency table, I'm asking you to do what we just did. Even without the highlight, you don't even have to throw that in there. If I ask you to plot the frequency distribution, I'm asking you to do what I'm about to do, what we are about to do. All right. You can do this one of two ways. You can grab the midpoints and the frequencies, or the midpoints and the relative frequencies. Either way, if you do it one way up here, you need to do it the same way down here. Okay. And so let's go ahead and plot those. I'm going to use the midpoints. Oh, that's the other thing I was going to say. That's the midpoint's sole purpose. All right. They're going to become the values on our x-axis in our chart here very quickly. Okay. So don't grab the group designation. I want you to grab the midpoints. That's why they're there. All right. That's the only purpose they're ever going to serve. All right. So with that, I'm going to go insert, remember. And if this doesn't come back, you want to practice this a couple times. Connected scatter plot, bam. All right, good enough for now. I don't like how it's so thin and all that, but that's fine. Okay, so there it is. I don't like all this white space, but if you leave all that white space on the exam, I'm not going to have a problem with it. I will show you something that I might have more of an issue with here in a second. Okay, so I have all this stuff. Now, average. If I asked you, hey, what is the average for this first group? We know we're going to put in average, or we're going to add all these up and divide by 12. Either way, whatever way you prefer doing. For the median, the easiest way is to type in median. Go ahead and highlight the same array. For range, I'm going to do this all at once, but actually I'm just going to break it down. There's a number of ways I can do range. If I'm concerned about going too fast and stuff, then I can just put the max down here. And to get the max value of this, I'm just going to highlight all that. And to get the minimum value, I'm going to do the same, but with the function minimum. Now, range is maximum minus minimum. So I can just put this minus that right there. Or I could just look at this and go, okay, are these in order? Yes, they are. Well, that's the maximum and that's the minimum. So 144 minus 100 is 44. Either way, okay, as long as it's correct, ideally. Standard deviation, because these are populations, like Lauren tells us all the time, we're going to use .p, and we're going to highlight that same array. Boom. Now, just as a side note, let's look at the relationship between the median and the mean. They're not the same. One is 123.91, and the other one is 124. But man, they are really close. Okay? And just looking at this here, this thing looks more symmetric than non-symmetric. So why do I bring that up? Well, when we have that going on, we can look at the standard deviation and say something like, when we take that average, let's just round it up to 124 and add the standard deviation. Let's just round down to 13. So 124 plus 13 is 137 on the high side. 124 minus 13 is 121. And that matches us yellow box up here. Okay. So that means that the heart, the tendency of this group is to be between 120 and 139, maybe even tighter than that, 121 to 137 kind of thing. So that describes the tendency of this group. And then the standard deviation and the range describe the variation among those scores, the spread, and potentially the consistency. Okay. So what? That tells us all about this population up here. Well, remember back to our beginning, we want to pick the 12 workers with the higher IQ. So this looks pretty good, but we don't know how this compares to that. So we'll go ahead and do this process down here. So same process to determine frequency. We're going to count how many between 100 and 109. That's 4. How many between 110 and 119? That is 5. How many between 120 and 129? That's actually 0. You see, we don't have anybody between 120 and 129. And how many between 130 and 139? That's actually 0 too. Interesting. And then how many above 140? Well, we have 3 people. Interesting. Again, check ourselves before we wreck ourselves. We're going to add this up. That gives us 12. We match that against the number of people in the population. That's all good to hook, so we can rock on with this. We're going to grab that frequency. We're going to get cached up, protect that H value, 0.33, and that allows us to go to town and drag this all the way down. Interesting, these zeros in the middle. Cumulative frequency, we're going to grab that top value, just put it on over there, boom. And then we're going to add what I call the catty-cornered values. In plain English, the previous cumulative frequency plus the row's relative frequency. And let's just check this out. Boom, 0.75. That means that 75% of this population has an IQ of 119 to 110, or excuse me, 119 to 100 versus, so up here, when we do a 1 minus on that 0.33, it essentially equals 0.66. That means that 66% of this population has IQs greater than 119. This value here means that 75% of this population have IQs less than 119. So these are just kind of things to pick up as we go, so that by the time we get to infer what all this means, it just falls out of our pen, falls out of our fingers. Those mad skills are just all over the place. Now, we want to drag from that second cell, cumulative frequency. We have that beautiful 1 right there. Look at these 75s. What does that mean? That means that from this point on, nothing changes. The only reason we get to 1 is because of these suckers out here in this high category. Okay, let's keep going. We're gonna figure out average, median, range, standard deviation the same way we did before. Zoop. So again, the purpose of doing this is if I ask you, hey, tell me what the median is for whatever, you've got a quick way of doing that. There's other ways to do it. This time I'm going to do a combined way on range. I'm going to put all this in the same. So I'm going to equal max. And in the same equation, I'm going to do minus the minimum. Okay. It's the same process of what I did up here. Just when I did it up here, I broke it out. Down here, I didn't. To each his own. Okay. Both ways are, quote, correct. And then standard deviation. Again, if I call this a population, which it is, there were 12 people here and I got all the data. There wasn't any sampling involved. I've got to put .p. And especially I'm comparing apples to apples. So these are both populations. I wouldn't want to use .s down here and .p. That just would kind of mess up my stuff. Okay. Now, if I got a plot of frequency distribution, I'm going to do that. Again, I'm going to grab my midpoints and my frequencies just like I did before. And I'm going to go grab, insert my connected scatter plot. Good friend of mine. All right. And pull this sucker down here. All right. Now, remember before I told you, and I'm sorry this is so doggone tiny. Can I get it bigger, bigger, bigger? All right. Maybe too big. I forgot to talk about my Dos Equis guy. He's not my Dos Equis guy, but since I called this dose populations, meaning two populations, somehow I just thought of the Dos Equis guy. Sorry. Anyway, so check it out. My x-axes just happened to be the same units. I didn't plan that. Excel kind of hooked me up on that. You see that? I got 0 and I got 160 out here. I got 160 and I got 0 there. Cool. But Excel kind of went to sleep on my y-axis. Check it out. It goes from 0 to 6, but up here it goes from 0 to 3. I don't like that. Okay. I want these axes to be the same. And that is something I am going to get kind of a little excited about, just a little bit. So there's a simple fix to this. I'm going to right click here. I'm going to format this axis. It's going to go over my Dos Equis guy, but it's okay. He can handle it. I'm going to put 6 in there, and that should set this thing straight. Get rid of this. I don't need it anymore. All right, cool. So now double check. I have a 6 up there. There we go. I got 0 to 6, 0 to 6. All right. And if you want to put icing on a cake, you could change this x-axis to begin probably at 100. That would stretch this out a little bit, get rid of that white space. Of course, if you do it down here, you got to do it up here. But that's icing on a cake. Different from something that's more essential. Okay. So if you don't do that, you don't fix this white space, I'm going to be neutral about it. Okay. If you were presenting in real life, I would say you got to get rid of that white space, kind of thing, but we're not. So anyway, so here's the moment of truth. What does all this stuff mean? Okay. Now we have 7 days until the final. We'll talk more about those 7 days here in just a few moments, but the bottom line is what I recommend to you. You know yourself. You live with yourself 24 hours a day. If doing what we just did here wears you out, we got to do something about that. Okay. We want to get you more to the point to where you can do this stuff, what I just did, these tables, these charts, without, I don't want to say not even thinking about it, but where it's not much work. It's an old friend coming over for dinner, kind of catching up kind of thing. And here's why. You don't want to expend your brain power on that. You want to expend your brain power on what I am about to do, which is to answer the $1 million question, which group do we pick and why? Okay. So if I was trying to divide it up, I think ideally it's the whole Dakova thing. Spend 25% of your energy getting the mathematics, spend 75% of your energy on the interpretation. Now, if the mathematics are incorrect, your interpretation is going to be flawed. I got it. But what we just did here, for the most part, is like riding a bike. Okay. And with enough practice and repetitions through that practice, we can get it so all of you can be doing that and Snapchatting and, Instagramming and rubber chickening at the same time. Okay. So moment of truth. What does all this mean? What group do we pick? Well, let's just lay it out. Here, our greatest concentration, the tendency of this group, 50%, is between 120 and 139. We have a relatively symmetrical population, so nothing's skewing anything either way. And so that means that this average here is very characteristic of this population, 123. And its highest concentration, 50%, is between 120 and 139. Let's look at this one. Well, first of all, the average is lower. Okay, 123, 118, that's a difference in about 5 IQ points. Furthermore, the average is not really the best descriptor of this bottom population. And here's why. The median is 4 points lower. And what does that tell us? That means, no pun intended, that something is pulling this distribution to the right. It is skewing it in the positive direction. And if we check it out, it's these 3 folks right here. So if we were to take them out, which we're not going to do because we already hired them, look at the rest of the population. The rest of the population is squarely down here, like we talked about. Okay, 75%, that's what the cumulative means, is between 100 and 119, which is really even lower than what that average is. That's why that median in this bottom case is more of an accurate depiction of kind of the tendency of this bottom population. So if we compare tendencies, 123 versus 114, this is the higher performing group with the higher IQ. If we look at variation in terms of consistency, this group has more variation in their scores. That's caused by these 3 folks down here. If we took these 3 folks out, they wouldn't have as much variation, but that means that they're going to be consistently lower, and I don't mean that IQ is IQ. It's not everything, but they're going to be consistently lower. So, even if we took that out, it still doesn't really do this group much good to us or towards our choosing this group over the first group. All right. So I think Delaney's decision as the executive would be, we want to choose this group for the jobs that require higher IQs. Okay. So is there a step-by-step method on how to interpret data? Unfortunately, no. But if we use all of our descriptors and we are comfortable with what they mean, then the interpretation will flow. Okay, will flow. And some of that just may take practice in doing the descriptors and thinking about what does this mean and feeling comfortable about what cumulative frequency means versus relative frequency. Okay, so it is very likely that you'll be given one of these populations, and I'll ask you to do it for the other and then compare and make some decisions based on your interpretation. Are there any questions on what we just went over here? Big or small? Okay. It's not a one-time question. So if you're like, hey, I was lost in the sauce, then that's cool. It's not so bad to be lost in the sauce. It's good that we know where we're at. That's the most important thing. Okay. One more slide. Actually, 2 more quick things, and we're starting to turn into pumpkins. Let's talk about how to prep real quick. And I don't want to preach, so if this sounds like preaching, I didn't really mean to do that. I don't like preaching to warriors. Anyway, so a lot of stuff on this slide. In my mind, this is a hierarchical sequence. So you don't want to skip down here and grab something down here. If you're going to take any of these recommendations to heart, I would recommend you start with the top and work your way down. These first two things, it sounds like a lot. You should be able to do this in about 5-10 minutes. I think all of you I would be surprised if you spent more than 5-10 minutes on these two things. Number one is assess and decide. What do I mean? Assess meaning where am I at in this course, both grade wise and knowledge wise, and where do I want to be by the time the smoke clears at 7, whatever, or 8 o'clock next Tuesday. Do I want to I have this much knowledge? Do I want to have this much? I'm currently in an 85 and I want to have a 93. I mean, all those decisions are up to you. Okay. But the old saying goes, if you don't have a plan, any road will get you to where you're trying to go. All right. But if you want something out of this whole thing, then it's key to assess where you're at and decide where you want to be, and then therefore how much time and energy you're going to put into getting there and breaching the gap. Again, I think most of you kind of already intuitively know that. You may want to confirm some of that by looking on Canvas and all those kind of things. 2, assess your strengths and weaknesses. I say both initially and continually. Initially means where you're at right now. Okay. Hey, I love hypothesis testing. When you say sampling, I run away and I get in bed and I pull the cover over my head. Okay, cool. That's where we're at. But when I say continually, that might change tomorrow. Tomorrow, you might find something new that you're strong at, and you might find something new that you want to do a couple more turns at. So assessment doesn't ever end. All right, but you definitely want to do an initial assessment. So I think these first two things will probably take you about 10 minutes together. The third thing, take a little bit longer. Organize for combat. You know how I feel on that. What I mean there is get your formula sheets out and start tweaking them. Okay, at least know where they are within arm's length or computer kind of click, 2 clicks away kind of thing. I think the sooner you do that, the more productive, because once you start doing reps, it's kind of less effective to do a rep and not have your formula sheet that you're going into combat with there in your hand. So that third step might take you a little bit longer, but probably not too much. Fourth thing, attack Joker's Wild earlier than later. What is Joker's Wild? This is Joker's Wild. This is what we're going to do on Thursday. This is our final and ultimate we drive. It's got sections in here. It's got about 5 sections in here with problems. This looks kind of familiar. All right. So are you going to turn this in for a grade? No. All right. Do you have to do any part of it? No. Who wrote it? I give you one guess on that. I will give you the answer to it in digital copy later this week. On Thursday, we're going to pull this sucker up and we're going to Q&A time. Hey, Carrie, how would we approach this? Hey, Anna Grace, how do you think we do this? Again, it's never to stump the chump. It's always for prep. What I recommend, again, it's up to you, is, earlier than later, maybe even after this call, you pull this thing out and you start going for it and you get as far as you can. Maybe you say, hey, that looks like descriptive stuff. I don't want to start there. Maybe you jump down here to quarantine. It's a hypothesis test. Maybe you start here. It depends on your assessment. Okay. But that way you come into Thursday and you're not seeing this for the first time. I think the Joker's Wild is the best packaged prep, kind of one-stop shop that is out there. It doesn't mean that you shouldn't look at other things too, but I'll just leave that at that. Identify and send questions. Hey, I'm either on this Pearson problem or this part of Joker's Wild. I am just stumped. identify that earlier than later. That gives us more time to help you get unstuck. Okay. And when I say send questions, send them to your fellow warriors, send them to me, send them to, somebody, kind of thing. And if you want to get reading day reps, sign up for some reading day reps. Okay. I'm not going to quote shut my door. So like at Friday at 3, I'm not saying, hey, I'm never talking to you again. If you got a question on Saturday, if you got a question on Sunday, if you got a question on Monday, you know the deal. If you got a question on Tuesday, you know how to get hold of me. That's not what I'm saying. I'm just identifying that day so that if you got questions, we can go for it. All right, way down the list, selectively attack, practice packs, and practice Pearson. Again, it's not that those aren't valuable. I just put them lower in the hierarchy because I would want you to exhaust these things first. Okay. Keep track of reps. That might not be something you traditionally do. But the reason I say keep track of reps, you want to say, okay, I've done these many reps on hypothesis testing. I've done these many reps on sampling. Hey, I haven't done any reps lately on regression. So am I assuming risk unnecessarily? Or what do I need to do there? It isn't necessarily that you need to do reps on everything, but keeping track of where you spend your time forces you to kind of think about how that time spent is productive as opposed to just grabbing problems and doing them. None of you are suckers, so that's not what I mean. But the analogy is if I just go to the gym and I grab a barbell and I just start cranking reps out and I'm not thinking about what that barbell's doing to my body and what I want it to do, I'm not going to say I might as well not go, but I'm kind of down there with wasted time. So what I don't want you to do is go through problem after problem of Pearson or Joker's Wild and say, hey, I have no clue of what I'm doing. I would rather you do less problems, but have more confidence in both what you know and what you don't know. And then finally, and it's down the list there, the more stronger you get, don't be afraid to put yourself on the clock. Okay. It's kind of like a forced repetition where, okay, I have this problem and I'm going to put my timer on 10 minutes or 15 or 20 or wherever you're at, but never putting yourself on the clock is probably not a good thing because the truth is, I don't wake up in the morning to put you on the clock, but we all have different perceptions of time, and never inducing that stress on ourselves in preparation is probably not a good idea. Okay. So going into the exam and being constrained by time for the first time is probably not a good thing to do. We want to at least constrain ourselves on time at least a couple other times before we go into the big day. All right. Those are just some suggestions. I don't mean to preach, so I will shut up. Just thoughts on my mind today. Whatever way I can help you throughout this next week. Any questions on anything, any comments, anything at all? Anything at all? All right. Okay. As always, I will stay on and clear the call. Once you do, I'll post this video, and so you'll have it. And I'll post the other things that I talked about, the filled in portion of dose pops and all those kind of things. We will begin on Thursday, probably with a few kind of alibis from this, like on how to write the symbols in Excel and maybe some keywords on identifying independent variables. But I'll try to make that very fast and succinct. And so we'll spend the bulk of, really the majority of the time on Thursday getting into Joker's Wild and attacking that thing with vigor. So if I don't hear from you or talk to you between now and then, have a great week. Stay in the fight. We'll see you.
Hey, Dr. Shatskin. I just want to make sure that I'm good for not having my camera on because we did talk about it earlier.
Yeah.
Okay, I was just making
Absolutely. I appreciate it.
sure. Have a good one.
All right, you too, Cameron. Take care.
Thank you.
Miss Carrie. No, Miss Carrie.